It's my pleasure to introduce you to Mr. Kundan Das, the founder and CEO of 4.0 Smart Industry Advisory Services. He brings over 20 years of expertise in engineering and business. With a professional experience in engineering and product management and product ownership across AI and ML, telecom, and datacom domains, Mr. Das holds over 11 US patents in mobility, edge computing, and core network technologies. His leadership as a former senior director and director in global business and his affiliation with the World Economic Forum's AI and Climate Change Initiative reflects his commitment to innovation. Mr. Das has focused on optimizing Agritech, Defense Tech, MediTech, and Edutech manufacturing plants, fostering continuous improvements. Today, we are honored to have Mr. Das as a guest speaker, and he will talk about Industry 4.0 and evolution of manufacturing. So without further ado, let's welcome Mr. Das.
Thanks, everyone, whoever has joined, wherever, and my fellow panelists. So I represent Forto Smart Industry. We are primarily focusing on advisory services and working very closely with manufacturing companies, automobile companies, healthcare companies to bring smartness and deploy use cases which are going to be finally address the KPI or performance improvement for the specific enterprise and verticals. Okay, so I have my education with ISP, Hyderabad. Then I've done Industry 4.0 and Digital Twin from Hong Kong University. And prior experience working with Lucid, Huawei, Cisco, Bytewal, Parallel Wireless, or G-Star, which are primarily in the mobility domain. And as you know, like the Industry 4.0 has a component which is quite new and recent, that is the private 5G network. So the areas of expertise that we offer is 5G, artificial intelligence, blockchain, digital services, digital twin, compute, healthcare, IoT, telco cloud, and our offerings are skill development, because we strongly believe that in India, if there is a bigger gap which is there among all the ecosystem partners who are responsible for making Industry 4.0 or manufacturing 4.0 successful, that is the skill set gap. And of course, there is a lot to do on the policy front as well. Then we also have our segment that is factory auditing with Series. Series is a assessment tool that is by World Economic Forum and all the Industry 4.0 participants and owner or ecosystem partner. So Series A index that is followed in auditing of a Industry 4.0 migration. Basically, to understand if I have to go for industry migration to Industry 4.0, whether the factory is in 2.0 or 3.0 or it is at 4.0, and wherever it is, what is the gap and what is the assessment and what is the strategy need to be followed to migrate to that particular index with respect to its competition. We also follow the standard like RAMI 4.0, which is for Industry 4.0, the benchmarking standard that is across connectivity and process optimization management. We formulate GTM strategy, go-to-market strategy for industries, program management, intra-planning of network 5G and edge compute, use case and KPI improvement. So these are our key offerings as part of the 4.0 Smart Industry, our organization. So as you all know that the industry has evolved from last multiple decades, from Industry 1.0, Industry 2.0, Industry 3.0, and 4.0. If I look at closely with respect to the linkage it has with particular manufacturing, in the past when it was 1.0, it is more of a modernization in the manufacturing, introducing steam and water power engines. And that time the production focus was primarily in the iron production. And with the introduction of steam and water power, the iron production has gone up by 3 times than in comparison to what it was before. Then we move to the next modernization of industry, that is 2.0, where assembly manufacturing, particularly from the European and US companies. So there we have seen a jump of 7 times in terms of the car production by with the adoption of Industry 2.0. Then 3.0 is basically the initial adoption of automation with programmable logic control, SCADA, ABS, those kind of automation practices on the shop floor. So Industry 4.0 is basically now where we are in. That is primarily making the industry smart with connectivity, IoT, artificial intelligence. It's basically a collection of data from all kind of machines. And the machine data is basically the intelligence that a factory can get. And with the analysis of the intelligence, the productivity and efficiency and KPI management need to be focused and need to be targeted for a positive improvement. So this is the migration story that we are following up in the Industry 4.0 till now. But Industry 4.0 is a lot to do or much bigger to do because it is bringing the digital transformation from a traditional enterprise which was focusing digital transformation in office or IT environment to a operational technology that is the OT environment. So the difference between IT and OT is that, or the office and the shop floor, is that the kind of devices that you're using in a office environment are primarily PC, laptop, and phone. But when you go to a shop floor, the device is diversified to much larger domain. It could be sensors, it could be drones, it could be IoT devices, meter devices, the calculation of number of employee steps, video camera analytics. All these kind of devices are going to provide data, and using the data and analysis of the data, you have to deploy the use cases, and the use cases are targeted at how the efficiency and KPIs are going to improve. So if you look at Industry 4.0, it's a much bigger market and expected to be around $13.2 trillion by 2035. But the largest segment of the market is the smart manufacturing, or which is the manufacturing 4.0. And of course, the other segments are again healthcare, logistic, all are again having going to be benefited with Industry 4.0 migration. But manufacturing is standing at the top. And as you know, like India is moving to the next phase of its growth story with diversification and large-scale manufacturing. So it is critical for us and for Indians to look at manufacturing 4.0 as the next big investment from all components or all segments of the ecosystem. However, if we look at today, with respect to countries like Germany, Korea, and China particularly, we are standing like negligible in front of them. Okay, and why so we'll be discussing, and I'll be love to have my panel's thoughts on that because that's the most crucial thing, because it is largely dependent on the policy. Okay, so though government has taken a lot of policies in favor of business, but we are not finding Industry 4.0 in manufacturing is picking up to the extent possible what China, Germany, US, and Korea has seen. Okay, so when we talk about Industry 4.0, that time the key expectation we have to look from a enterprise requirement rather than what exactly we are offering. Okay, so if we look at an enterprise, the enterprise has a very simple requirement. The enterprise counts its performance based on certain KPIs. Now, whatever we do in terms of network, artificial intelligence, machine learning, IoT, anything to everything at the back end on the technology platform, absolutely not of any interest for the enterprise if the KPIs are not improved. So the key objective is that whatever we do in the entire end-to-end ecosystem or end-to-end process, if it is not aligned to the KPI improvement, story. There is nothing else, period. The components like deployment of 5G network, like if I look at only 5G is contributing only 9% of Industry 4.0 investment. But unfortunately in India, we have only the 5G players who are going to drive Industry 4.0 as per government's direction. Target to achieve investment of 5G based in communication, that is, forget, like, because 5G has two different networks. One is a public network. In public network, public KPIs are related to call drop, delay, or speed, and all those things, which are fine. But in the enterprise, it is end of the day whether the robotics movement, whether the automation, all those things are working in line with the production requirement. If it is not, then 5G, 6G, Wi-Fi doesn't matter. But qualitative and quantitative. So the key performance parameters are again related to those which are finally going to address to the KPI. Now, if I look at to the two different who all communicates in a industry, who all communicates with whom, it's machine to machine, person to machine, things to machine, all are again connected and communicating with each other. Technology requirements are multi-diversified, starting from chipset, sensor, cloud technology, IPv6, data analytics. All these are the technologies, but finally, end of the day, you are going to have the deployment, which is in layer. Like you have to connect first the devices layer, which is at the bottom. The devices layer are basically the one which are going to give intelligence using a network that could be 5G, and 5G can be used for IoT, industrial IoT. Then it is further going to be communicated to a cloud where analytics and analytics of data, those are going to be there. Then based on the analytics, you're going to develop applications which are focusing on use cases. So there are multiple use cases which comes to light are factory automation, process automation, HMI, and production IT, logistics, warehousing, monitoring, and maintenance. So everyone has use cases and certain use cases which provides multiple value with respect to the particular production unit. The one that I'm going to take example is digital twin. Can you play the video of digital twin?
Hello and welcome to our video on the benefits of using a digital twin in smart manufacturing. A digital twin is a virtual replica of a physical product, process, or system. It can be used to simulate and analyze various aspects of the manufacturing process, including design, testing, and performance. By creating a digital twin, companies can gain valuable insights into how their products and processes will perform in the real world, without the need for costly and time-consuming physical experimentation. The use of a digital twin in smart manufacturing can bring numerous benefits, such as improved design and testing, increased efficiency and productivity, improved communication and collaboration, and many.
Every company has
here
its
I have
secret.
one of the case which is so we are taking the case of Tesla, how Tesla has gone for adopting automation and intelligence, AI, and all those new features and functionalities of Industry 4.0, and how the three Tesla manufacturing unit, one in US, Berlin, and Germany,
And Quark.
and China, how they have gone for adopting more than 75% automation, and the growth story of Tesla with respect to Toyota, which used to be the market leader, how it has shifted after adopting this kind of Industry 4.0 automation and intelligence platform.
Every company has its secrets and quirks, but Tesla is even more notable because of its incredible factories and how many cars it can produce. Did you know that in 2020, the automotive company produced about 509,737 vehicles? So how are they able to create so many vehicles in a single year? How exactly do they do it when so many other companies can't even get close? AI Factory Magic. After Tesla bought its automotive factory at a fraction of its original cost of $1 billion for just $42 million, it embarked on a mission to build the most advanced automotive factory in the world. They added top-tier equipment, which includes lots of AI-powered robots. The factory is located in Fremont, California, and sits on land that spans the size of 185 football pitches. That alone is impressive. Elon Musk defines Tesla's Gigafactory as the machine that builds other devices, and this is because of how AI powers it. In 2014, when construction began on the Gigafactory Nevada, it started as an experiment, but now it is a significant identifier of Tesla's success. Elon Musk's Tesla has other Gigafactories in the works, like Giga Texas, Giga Berlin, and Giga Shanghai. And since the Giga Nevada...
But if you look at here, the key things which Tesla has adopted is machine learning, predictive maintenance, and artificial intelligence. And if we look at in the last 4 years, particularly 3-4 years, how with respect to Toyota, Tesla has clearly got a leadership position in manufacturing, and in car premium it is now, it owns around 8 times higher premium than that of Toyota, which is the market leader. So this is all possible, and this is a great achievement when we adopt technology targeting or focusing on efficiency management of factories and manufacturing. Anything lags behind, then definitely manufacturing is not going to be that efficient or that big as a success story, which we all are focusing right now in India. So how India is looking Industry 4.0? Till now, if my personal assessment is that we are standing at a very low adoption of Industry 4.0, particularly for manufacturing. Even though we are successful in automobile, we are successful otherwise as well, but the actual application and implementation is at the lowest point. The skill set gap of the skill set in India in Industry 4.0 across all components are close to 4%, than in comparison to China, which is 38% right now. Indian manufacturer 4.0 is not a very big successful story. How can we evolve with highest level of success with Industry 4.0? That has to be the key focus that all of us need to be put our effort for. Understanding the skill development, primary gap need to be immediate focus, and that's why in our organization we have kept the skill development for our customers, that is enterprises, and working closely with different academia or management institutes. We are focusing this in a big way, and that is again across multiple things like manufacturing. There is a different skill set requirement. Healthcare is a different skill set requirement. Logistic is different. Agriculture different. Defense equipment different. So all those kind of things we are working out, and we have dedicated course of material for all of them. And we work very closely with enterprise in further stepping our courses. Experts need to lead, not licensing. In India, as per government's mandate, the adoption or the Industry 4.0 implementation can only happen with a operator, that is the 3 operator who are in India having 5G license. But that is not the case in case of US or Germany, Norway, all these countries which are leading the Industry 4.0 story, because in those countries, enterprises, they can have their own licenses. Now, once the enterprises will have their own licenses, they will decide how exactly they know what exactly to achieve and how exactly to achieve. So that's a major disconnect. Like for example, if I look at an operator, the operator is doing fantastic and it has all skill set of 5G. But does it know the industry process, industry KPI, industry performance gain, all those kind of requirements? Possibly no. So then the operator needs partnership with other components or other players to develop a complete ecosystem or a combined story or combined skill set that can focus on an industry. And the key thing is that not 5G to be deployed or 5G to be successful. It is the KPIs need to be improved for that particular enterprise. Then only we are going on the right track.
Thank you, Mr. Kundan, for sharing insights on Industry 4.0 and evolution of manufacturing.